Hello, hello. Okay. So before we start learning how to evaluate the six trigonometric functions with given a point on the terminal side and angles, we should review what we learned. So in this example, the hypotenuse of the right triangle is r, and this is x and y. And here we have the angle theta. Since theta is equal to the opposite side divided by the hypotenuse, so it's divided by y and r. Now keep in mind when dealing with a unit circle, r is 1. So therefore, the equation becomes sine theta is equals to y. But when you're not dealing with a unit circle, sine theta is actually y over r. It's equal to the opposite side divided by the hypotenuse. Cosine theta, according to Sohcahtoa, cosine theta is equal to the adjacent side divided by the hypotenuse. So the adjacent side is x over hypotenuse is r. Now that so tangent theta is equal to the opposite side divided by the tangent side in TOA. So it's y divided by x. Now cosecant is the reciprocal of sine. So if sine is y over r, cosecant as r over y. And secant is the reciprocal of cosine, so that's r over x. And cotangent is x divided by y, so they're just reciprocals of the sin costant. Now let's review the sign of the trigonometric functions. So here we have the quadrant 1, 2, 3, and quadrant 4. So if you recall, sine is positive in quadrants 1 and 2. Sine is associative with the y value. That means y is positive above the x-axis. Sine is negative in quadrants 3 and 4. Negative on quadrant 2 and 3. Tangent, which is y over x sine of a cosine tangent, is positive in quadrants 1 and 3. Tangent is negative in 2 and 4. So these are some things that you want to commit to memory. So in quadrant 1, everything is positive. In quadrant 2, sine is positive. In quadrant 3, tangents positive. And in quadrant 4, cosine is positive. Perhaps you've heard of the expression all students take calculus. So all means that in quadrant 1, all signs, sine, cosine, tangent, all of them are positive. Students, sine is positive. As for take, T is positive. Calculus, C is positive in quadrant 4. So all students take calculus may be useful in your endeavors in memorizing this. Now, for the examples, here we have, let's say we're given a point P, which is negative 5, comma 12. And so, on the terminal side of theta, we're going to find the values of the six trigonometric functions. So if you're given a point, what you want to do is you want to plot the point and also make the triangle at the same time. So x is negative 5. That means we have to travel 5 units to the left. Y is positive, so you have to travel up 12 units. And then draw the hypotenuse, which is r. So we know that this is a 5, 12, and 13 triangle. And here is the angle theta. Now let's go ahead and find the sine theta. We all need to find all the six trigonometric functions. So sine theta is which is y over r. Also, it's opposite divided by hypotenuse, where hypotenuse is r. So sine theta is going to be positive 12 over 13. Cosine theta is equal to the adjacent side divided by the hypotenuse. So it's negative 5 over 13. Tangent theta is equal to opposite divided by adjacent. So that's going to be 12 over negative 5. Now, once you have these three, you could find the cosecant. You just gotta flip this fraction. So cosecant is gonna be 13 over 12. Secant is the reciprocal of this one. So that's a negative 13 over 5. And cotangent is the reciprocal of this value. So that's negative 5 over 12. Now let's go to another example. Let's say we're given a point negative 8 and negative 15. So we have to find the value of the six trigonometric functions. So let's plot it again. So x is negative 8. So we have to travel 8 units to the left. And y is negative 15. So we have to travel 15 units downwards. So x is negative in quadrants 2 and 3, but y is negative and 3 and 4. So the triangle has to be in quadrant 3. Now this is going to be the 15-17 triangle. And here's the angle theta between the terminal side and the x-axis. So sine theta is going to be the opposite, which is negative 15 divided by the hypotenuse, and negative 8 is the adjacent side relative to theta. So sine theta is negative 15 over 17. Cosine theta, according to SOHCAHTOA, is going to be adjacent, which is negative 8 divided by the hypotenuse. And tangent theta is equal to the opposite side divided by the adjacent side. So the two negative signs will cancel, and we're just going to have 15 over 8. So keep in mind, in quadrant 3, tangent is positive, but sine, cosine will be negative. So cosecant, to find that, all you need to do is find the reciprocal of this value. So cosecant is going to be 17 over 15, but with a negative sign. And secant is going to be a reciprocal of cosine, so which is negative 17 over 8. And finally, the cotangent, which is 1 over tangent, that's going to be 8 over 15. And that's it for this example. Let's go on to another one. So let's try this one other problem. So let's say we have the point positive to negative 4. Let's begin by plotting down the point. So x is positive 2. So we got to move 2 units to the right. Y is negative 4, so we have to go down 4 units. Now this is not a special triangle, so we have to use the Pythagorean theorem in order to find the hypotenuse. So a squared plus b squared is equals c squared. So a is 2 in this example, and b is negative 4, and let's find the c. So the hypotenuse is always positive. So 2 squared is 4 negative, 4 squared is positive 16, and 4 plus 16 is 20. So we've got to take the square root of both sides and 20, and we can write it as 4 times 5. And the square root of 4 is 2. So that the hypotenuse is 2 square root of 5. Now that we have the hypotenuse, we could find everything else. So 2 is on the adjacent side of x into theta. Negative 4 is on the opposite side, and 2 square root of 5 is the hypotenuse. Sine theta, which is divided by y divided by r, is equal to the opposite side and divided by the hypotenuse. So it's negative 4 divided by square root of 2, which reduces then to negative 2 over square root of 5. And if we rationalize it by multiplying the top and bottom by square root of 5, it becomes negative 2 square root of 5 over 5. So that's the value of the sine theta. Cosine theta is equal to the adjacent side, which is 2 divided by the hypotenuse. So that simplifies to 1 over square root 5 because these cancel out. And then if we rationalize it, it becomes square root 5 over 5. Now, so that's the value of cosine. Oh, wait, I'm sorry. I didn't show the, oh no. I'm sorry about that. Now, next we have tangent, which is opposite divided by adjacent. So that's negative 2. Now let's find the value of cosecant. Cosecant 1 is 1 over sine, but what you want to do is you want to flip this portion of sine before you rationalize it. So cosecant is going to be negative square root of 5 over 2. And now for secant, we want to flip this portion before we rationalize it. So if cosine is 1 over square root of 5, secant is square root of 5 over 1. Or simplify square root of 5, and that's the value of secant. And here's the value for cosecant. Now tangent is negative 2, so cotangent is going to be negative 1 over 2. You just have to you just have to flip it, and that's it. That is everything. Thank you for listening, and I hope you learned from my tutorial.